Hello everybody, my name is Dr. Mahmou F Mubark, Doctor of Physical Chemistry, Petroleum Research Institute, Cairo, Egypt. First, allow me to begin my speech today by expressing my grateful for your kind invitation to me to participate in this estimated conference about nanomaterials and nanotechnology that is deal with most important properties of life and the most important for sustainable development process. And my presentation will be undertitled Synthesis of Cold-shell activated carbons, calcium carbonates composite from ficus nadia leaves as an efficient absorbent for removal of cationic dyes. My presentation will include the following: introduction about the problems and the water pollution and nanocomposites that we prepared in our research. Second, the aim of the work. Third, experimental work for result and discussion. And finally, the conclusion. In the introduction, at the outside, I would like to refer that is water, as we know, cover nearly 75% of the Earth's surface, and we found that it is divided into 97% of salty water, which is represented in the sea and ocean. What I mean by salt water, it is that the degree of salinity reaches to 35,000 milligrams per liter, and varies according to two types of salt water. And only 1% is drinking water, and is divided into 35% underground water and 2% only 2 are for rivers. And these rivers benefit some countries boundaries the rivers, not all countries having these rivers, so many people suffering for the earth and its surface. To imagine how much the rareness of the water is, let's suppose that if the amount or all the amount of the water on the earth 1 million cubic meter, we will find that the fresh water would be 30,000 cubic meter, and from this the surface water would be 19 cubic meter. The river in this water would be 1.8 cubic meter, and this is very small amount of water that is available for to be drinking water. And this amount, therefore, this water problems today or water shortage. This water shortage not only having a too little amount of water, but is also the release of pollutant in this water body will make a water pollution. Water pollution. What is the water pollution? Water pollution, it is an undesirable change in the physical and chemical or biological characteristics of water that can be harmful effect on the health, survival and activities of humans or other living organisms in the water body. Water pollution source. Water pollution source can be divided into mainly categories. Point source. Point source when the harmful substances are emitted directly into the body of the water. They include factories, wastewater treatment facilities, and other sources that are discharging pollutants into the water source. The second type, it is a non-point source. Differs pollutant indirectly through environmental change. An example of this type of the water pollution is when fertilizer from a field is carried into a stream by rain in the form of runoff, which in turn affect aquatic life and distribute many organic pollutants in the water that affect on fish and human and many other lives in the water body. Pollutants. Pollutants, there are many categories of pollutants. As we can see, floating matter like foams and oil and greases. Oil spill is a major problem in the world. Fiber-lined, suspended particles like estimated organic matters, microorganisms like bacteria and algae and others, sand and salt from the environmental rocks. There are another pollutants like dissolved matters, and this may be acid or alkalis from factories, cations and heavy metals from environment like calcium, copper, mercury and lead and so on. Anions, carbonates, bicarbonate, sulfates, chlorides, that is forming the salinity of the water. Organic matter like BOD and COD, phenols, hydrocarbons, and non-biodegradable compounds. Color from dyes causing compounds. Let we say In this work, we focus on the cationic dyes MV and PY28. Source of dyes in wastewater. Dyes come to the water body through pharmaceutical industry, textile industry, cosmetics, laser, paint and varnish, pulp paper industries, and many other industries. All of this put its dye in the water body and increasing the pollution or chemical pollution especially. Dye affect on the human and the other organisms and animals, causing many diseases like brain damage, heart disease, tubular damage in kidney, mental confusion, stomach cancer, and so on. Many diseases. It is harmful on the body, so it must be removed from the body or wastewater or the polluted water body. Wastewater conventional treatment methods. To remove dye from water, there are traditional treatment methods like chemical method, physical method, and biological method. Chemical methods mainly like oxidative process, ozonization. Physical method, membrane filtration, famous one. Biological method, decolorization by whitewood fungi. And many methods have a many critical limitation. Cost. Cost is a limiting point for many treatment processes. Second, insufficient and low pollution concentration. Low pollution concentration, this method cannot work with the little concentration. Huge time consumption, reagent and energy. Chemical sewage, sludge formation. So, we need to think out of the box. How? It is a time to come up with alternative cleaner and cheaper technology for the efficient removal of different contaminants from wastewater. Aim of our work. Our aim is focused on preparing an efficient adsorbent from natural waste material and environment, ficus nadia leaves. Also, to evaluate or removal of methylene blue and basic yellow 28 dye from wastewater by means of prepared adsorbent. Experimental section. First, purification and modification of ficus nadia leaves. Ficus nadia leaves, after collection and washing several times with water, it is dried and then crushed. Crushed leaves treated with diluted HCl and then treated leaves powder will be produced. After that, washing several times to reach the neutral pH. After that, we treating it with NaOH with high concentration and washed several times to obtain the cellulosic molecules. After the drying, we obtain at the end extracted cellulose without lignin and without other impurities in the fresh ficus nadia leaves. Second, preparation of calcium oxide activated carbon core shell nanocomposites. Extracted cellulose treated to distilled water. Second, we add 1 and 3 and 5% of nano calcium carbonates at the catalysis and the inner core of the core shell that will be formed in the future. Then magnetically stirred. We obtain activated cellulose in this step. After that, drying and keeping in the furnace for certain temperature, high temperature, so we obtain at the end of the calcination calcium oxide activated carbon core shell nanocomposite. The instrument used in this characterization techniques or this study: FTIR, SCM, Raman spectroscopy, UV spectroscopy, TEM and ADX, XRD, atomic absorption spectroscopy, and zeta potential measurement. Result and discussion. First, characterization techniques of calcium oxide at activated carbon core shell IR spectroscopy. We found in the case of 1% calcium carbonate, the small band at 515 cm - 185 vibration of calcium oxide bond, while in case of 3% calcium carbonate, the absorption band at about 1450 cm - 1, which is due to COH bending groups. In case of 5% calcium carbonate, the absorption band at about 920 cm - 1 assigned to COH out of plane bending. In the Raman spectroscopy, In the case of 1% calcium carbonate, as we can see from the figures, two strong bands can be noted in all spectra at around 800 and 1350 centimeter minus 1. The first band is associated with the CC single bond. In case of 3% calcium carbonate, the band appears at about 715 centimeter minus 1 is correlated to the calcium oxide, and the band at about 1216 centimeter minus 1 is related to OH substitution. So we can confirm the structure and the chemical composition from IR and Raman spectroscopy. With respect to the morphology, outer morphology and the inner morphology, SEM and TEM can be explained that. In SEM, we can found that we evaluate the surface morphology and the texture of the materials that is we prepared in our research. The nanocomposite produces a high, very porous structure and quite irregular cavities and pores that is located rough texture with a heterogeneous surface structure that is helping in the adsorption process. After activation, the cellulosic part of the fecus media leaves will transform it into activated carbon with an increase in the micro and mesoporous in its surface. In TEM, we can note it from TEM that is the calcium oxide nanoparticles has a clear core shell configuration and possesses an average diameter of 20 nanometer. EDX shows that the calcium is the domain element in the sample. Also, oxygen and carbon and other elements are also found in the sample. With respect to the charge on the surface, zeta potential can tell us about. Zeta potential analysis determines the performance of the activated carbon based on the surface charge distribution. Figure shows that the variation of zeta potential as a function of pH of the media. It was possible to determine the electroelectrical point, which indicated that the pH value at which calcium oxide at activated carbon core shell surface net charge is neutral. The value is 4.3 was obtained. With respect to the XRD for crystallinity and the crystal structure of the prepared material, the activated carbon amorphous structure pattern reduced significantly after being impregnated with calcium carbonate. The value of 2 theta at 37 degrees corresponding to the calcium oxide species that is confirms the transformation of calcium carbonate into calcium oxide. The characteristic peaks were highly in the intensity and narrow in the spectral width, indicating that the product were having a good cell crystallinity. With respect to the surface area and the PET analysis, the curve show or indicating that the tested material has a well-developed mesopore structure. In this work, the specific surface area of calcium oxide activated carbon core shell nanocomposite is about 1255.5 meter square per gram. Adsorption study and studying or evaluating the nanocomposite for the removal and adsorption of cationic dyes. As we can see for the both dyes at different batch parameters like pH, we found with increasing pH that is the adsorption capacity increase and the removal efficiency increase, as indicating a more negative charge that is increasing the electrostatic attraction between the dyes and the surface of the nanocomposite. Those we found that is was increasing the adsorption capacity due to increasing the surface active site. In case of initial concentration, we found that is mainly the two dyes decrease the removal efficiency was increasing the initial concentration. With contact time, we found that is the equilibrium time between 30 minutes. With respect to the effect of temperature, we found that is the BY is increasing with increasing temperature, but methylene blue decreasing with increasing temperature, indicating that is maybe some mainly physical adsorption more than chemical adsorption. With respect to the adsorption kinetics, to understand the mechanism of adsorption process, we found that is the pseudo-second order model having a high R-square that's indicating that other chemical adsorption between two components, the surface of the nanocomposite and the two dye. Adsorption isotherm, that is give an indication about the surface morphology of the material. We found that is a frontage having a high correlation coefficient and high value of N. That is indication for heterogeneous surface with different active groups on the surface that resulting from the carbon and the calcium oxide. So we're having a double function and more energy for absorption of this dye. With respect to the thermodynamics, we found that is the delta S having a positive value that is indicating a more entropy. In case of methylene blue, delta H having a negative value that is indicating the absorption process is exothermic process, and delta G having a negative value, so it is a spontaneous reaction. In the case of By, we found that is the delta S having a positive value, so more entropy, delta H positive endothermic reaction and spontaneous reaction according to delta G value. At the end, we can say there is successful preparation of calcium oxide activated carbon coating nanocomposite from ficus needle leaves. We do characterization for this prepared composite by FTR, Raman, SCM, TEM, EDX, and zeta potassium and PET analysis, and conforming its chemical and morphological and characteristic properties. Application of this composite for absorption of methylene blue and By dyes with a high capacity reach to 90%, studying different batch absorption parameters and optimize it for the prepared nano composite shell. Also, we can say that is methylene blue and By generally on the prepared nanocomposite with increasing in pH and time and initial concentration and temperature, they are increasing in the removal efficiency, especially for By. Methylene blue temperature only, we found it is decreasing with increasing the temperature. At the end, I want to say thank you, and I would like to thank you for your kind listening, and I hope that the presentation has won your admiration. I would like also to extend my thanks to organizers of the conference. I also hope that you will visit Egypt as soon as possible and enjoy its warm atmosphere and visit its tourist attractions. Thank you and goodbye.